Hi there, my name is Tony Abbey. We're here at Yangtze Museum in Chino, California. I'm here today to talk about finite element analysis loading actions. And with me I've got the Cessna A model from 1928. Now the reason I've chosen the Cessna here is because it is a monoplane. As you can see here, a single wing supporting all the lift loading that the aircraft takes. Now, when Clyde designed this, it was very revolutionary. Most people were used to the idea of a biplane being two wings, and between those two wings we could put lots of struts, lots of bracing, so very, very rigid type of structure. And most people were used to that idea. People seeing aircraft flying overhead, the general public, indeed the aircraft manufacturing companies, all used to the idea biplanes are the thing. So Clyde came up with this idea of the monoplane, and basically he then had a bit of a problem trying to persuade the public that this was going to be something that was strong enough and safe enough to fly in. And Clyde, being a good businessman, he came up with a rather nice stunt to show how strong his wings were. And we're going to look over here and I'm going to show you that example. Well, here we are at Clyde's great publicity shot. We've come via some biplanes on the way down, but now we're back to the monoplane, and here Clyde has got half the Cessna design team standing across the top of the wing, obviously putting a lot of loading going down, showing the strength of that wing. So if you remember the public looking at this picture, you're going to get a nice feeling about this aircraft. It's a strong enough aircraft. I want to go flying in that aircraft, which is obviously that's what the picture's all about. But as engineers, if we think about this, does it make sense from a physical point of view? And the answer is not really, because if we think about an aircraft flying through the air, we're going to have lift coming upwards. So here we have the guys putting the load downwards. We want the lift going upwards. Now it is just a PR picture. Clyde was very much aware of that. And back in the day, what would have happened was they would have taken the wing off, jigged it, and put sandbags to represent, turned it upside down and then put sandbags to represent that lift loading. But it's a good lesson coming back all the way from Clyde Cessna back in 1928 to remind us in finite element analysis it's very important that we get that loading direction going in the right sense. This is another example where pressurization can go wrong. If we think of this little bottle, for example, as a scuba tank, then the pressure is going to be inside, forcing its way out, obviously trying to explode that scuba tank. On the other hand, if this is a submarine down at the bottom of the ocean, then there's going to be a pressurization squeezing, trying to clamp and crumple the submarine at the bottom of the ocean. And it's very easy, just a flip of the coin, literally, we end up with the wrong pressure direction. So we need to be very clear in our minds whether we're talking about a scuba tank or whether we're talking about a submarine at the bottom of the ocean. We're going to see, again, the computer animation, how it's very easy to check that. Again, another very important thing to concern ourselves, pressure direction. And there we're going to talk about pressure normals facing inwards or pressure normals facing outwards. So far we've talked about the wing as if it's a complete unit. So we talked about the lift coming from the total wing surface here. But in practice, we have the aileron, which is connected here via, this is the aileron actuator. There's a hinge point here, another hinge point behind me. The load isn't coming through the aileron and then connected completely and continuously through to the wing. So we have to think about the load path, which is coming from the aileron through the pickup points, through these hinge points, back into the main wing. When we set up the FE model, what we can do is actually put point loads, which are just point loads coming up from the trailing edge of the main spar here, not put loading in via the aileron. In fact, we don't need to model the aileron at all. In fact, we'll see in the computer animation, we actually lose the aileron. We put in the appropriate point forces. Now you may say, well, okay, we have a point force, but then we're also interested in the moment coming from that. If we think about the moments coming from that, the moments are actually taken out by the control hinge here, these go in and they're picked up by the control circuit. So they're not actually carried by the main wing itself. So again, quite subtle, something we have to think about loading actions, load paths when we're doing a finite element analysis. Well, thanks for watching our video. We hope you found it informative and also entertaining. We'd really like to thank Yanks Air Museum for being our host here at Chino, California, and we look forward to seeing you in the next episode.